Okay, so I just want to go over the stair tool and cover the main features, but then also have a look at some of the different things you can do to make different kinds of stairs. So I've gone to the view there where you can see that you've got the internal access stair shown in plan. And then, of course, you probably all know the stair tool lives on the architecture tab. You'll see in that circulation area you've got stair, ramp and railing together. And that makes sense. And so with the stair tool, the first thing you should be looking at is what it gives you in properties when you first go to make your stair. So notice it picks up the level of the plan that you've opened, and then it picks up the level above that. So before I do anything, I'm just going to cancel this stair and show you what would happen if I've got another level. And so say you've made a mezzanine level that goes in between these floor levels. So this might be ground mezzanine. Okay, so I've got that extra level. And so now, if I go back to that ground floor plan and do the same thing as I did before, notice that it's picked up the top level now as that level that's above my ground floor, my new level. And so that's really important because that gives you the calculations for the number of rises that you need. Okay, so do you all know the maximum height for a riser? Or does anyone know? Okay, that's right. That's the tread depth. So the the minimum tread depth in a public stair. That's right. Yeah. So the minimum tread is 250 in a public stair, which is what we're doing. But yeah, the maximum riser height is 190. So notice here, it's telling me the actual height is 216. So what's going on there? It's gone over 190. So that's because I've got a different kind of stair selected to what you would have. So I'm going to go back to the default one, and straight away you can see it's flicked back to 183 riser height, and it's giving me 13 risers instead of 11. And that's all because of the settings. When you go to edit type, you'll see it has the maximum riser height set there. So I'd made one with a higher riser because that was a spiral, and you can do higher risers in spiral stairs. But for this one, it's 190, and that's what it should be normally. So do you know how to calculate that without Revit doing it for you? Have you done a class on stair design? Often you will at some point, but not always these days. Often don't get time, but we always used to. So with the calculator, you can always just calculate the distance between your levels. So if I go and look at the section, you can see it's going to go straight to level 1. So 4485 is the height of that level. And then you divide it. What do you think you divide it by to work out the minimum number of risers? What would you divide this number by? Exactly, 190, right? Because that's your maximum riser. So this is the old way of doing it, but it's still something you should do, even though Revit also does it for you. So then it gives you 23.6 risers. Can you have that? Can you have 23.6 risers? No, you can't have 0.6 of a riser, so you round it up to the nearest riser. So that gives us 24 risers minimum. Right, so 4485 again is our level height, and now we know the number of risers, so we divide that by 24, and that gives us the riser height that we need if we have the minimum number of risers. Now, do we need to have the minimum number? No, we can have more than the minimum. So if you decide, well, I actually want a slightly lower riser, and a lower riser is nicer. 175 is a much nicer riser than 190. So you might say, okay, I want 175. So we go 4485 divided by 175. Gives us 25.6. So we say, okay, we can't have 0.6 of a riser, so we say 4485 divided by 26 or 27, and that gives us 172. So that's the way you can calculate how many risers you need, and it's good to keep on top of that even without Revit doing it for you. And if you're drawing in AutoCAD or doing it by hand, that's exactly how you do it. But again, Revit does the calculations for you as long as you've got the right level set. So going back to the plan, I've got ground floor, and now I'll make sure the top level is level 1. And then it already knows we need 24 risers minimum, and it's telling us that the riser height's going to be 1 over 3.5. I might decide, well, again, 24 maybe is not enough for me, so I want to add a couple more. Hit apply, and then we go down to 172, like I just showed you, and so that's still going to be okay because we need a landing either way. Do you know the maximum number of steps you can have in a flight before you need a landing? Exactly. Yep, that's good. So if you're remembering these figures, that's all you need to be able to design your stairs. Those two figures, the maximum riser and the maximum number of stairs, the most important, and your tread depth. And the tread depth I should show you is here. So that's 250, which is generally the minimum. But for your internal stairs, do you know what the other one you can use is? You can go down to 240 for private stairs. So the ones inside your units, you can go down if you need to. Okay, so we've got those settings. So then how do I go and make the stair from here? If you've been playing around in properties. Oh, you can do reference planes and all those things to set it out. That's really handy sometimes. But then to draw the stair, you've got this run tool. And then it gives you the different shapes. So they're all useful, but the most useful are the straight one and then the centre end spiral. They're the two you'll use the most. So the straight one for straight stairs, of course, and then the centre end spiral for curved stairs. You only use the full step spiral occasionally. Spiral stairs are difficult in a building like this because you need a landing. And a spiral stair with a landing is difficult. So then the L-shaped and the U-shaped winders are really only meant for winders. So don't use them for L-shaped or U-shaped stairs. They don't work properly. So here, this is a U-shaped stair. But I'm going to use the straight stair tool to make it. Okay, so this is, again, still just looking at drawing stairs, and we'll get into all the properties in a second. So I've got the location line there, which will start on run centre. I'm going to change that to run, well, I'll just ask you. I want to draw the stair along this wall. Right, down here. So which location line option do you think would work? Well, you might think so. If you're looking at it the way we are on the screen, that might make sense, but you need to think about it the way you'd be walking up the stair. So if we're facing that stair, the wall's on our right. Oh yeah, so from up here, but I want to draw it. I'm going to use a trick, basically. Yeah, so you're right. If it was from here, it would be. Yeah, you're right. But I'm using a trick. I'm drawing it back to front. So yeah, so in this case, it's run right. And then I can draw along the wall there. And then come across and notice it's counting the treads for me, but they're not lining up exactly. So that means the treads in the plan are bigger than what I've got set. So I'm just using the tape measure tool there to measure that distance, and we can see it's about 275, I think, or maybe even 280. Yeah, 280. So, no problem. I'm just going to change the tread depth over here to 280, and then go back to run, and draw the side of my stair along the side, and now you can see the steps line up pretty well, but actually they're going past it now, so I'll go back and try 270. And that's still a little bit too much, so we'll try 260. And there we are, so that's lining up perfectly. Okay, so it's worth just getting that right, because then you can line things up. So now I can see I've got 9 risers created, 17 remaining. So that's fine. And then I think what they've missed out here is that there must be a couple of steps going this way, and then it comes around again. So I'm just bringing it across, and then I'll come up a little bit above that point. I'll show you what happens if I go too far down. It'll let me make the stair, but the way it then joins them is a bit exchange. So we don't want that. So you need to make sure when you're joining your different runs, make sure you've got enough room for the connection. So I'm going to come up a bit above that edge and then just come up one step. That's all I can fit in there. And then now, coming around to this corner, I'm going to make sure I'm to the left of this edge here. So the basic concept there is that it creates the landings for you. But if you don't allow enough room for them, it won't connect them properly. So coming across now, and we've still got to get, how many? Another 6 after this. So I'm going to come to there. Okay, so then we've got to come back down. Again, just one step. Oh, now sorry, I'm drawing on the right. So the other side, on the edge of the wall. One step is all I need there. Okay, so then to finish it off, oh, now, sorry, this trick of mine maybe isn't going to work. No, it will work. Okay. So now I'll come to this edge. Oh, no, sorry, we're doing it to the right, so down to here. And we can go over the first one. So showing this is the first stair you have to do because it's actually quite a tricky stair. I'm going to finish that, and then you'll see, yeah, don't worry about the baluster. A couple of simple things you can do now. Maybe I'll show you in 3D. Okay, so you might realise that this part of the stair should be on the other side. So I can flip the whole thing now using mirror. And I'll just pick one of these edges. And it mirrors it, but it's giving me a copy. So you can either delete that or turn the copy off and off when you're mirroring. Okay, but again, it's a tricky stair to work out if it's your first one. So I'm just going to go outside the building and make a couple of stairs with the same settings now, just to give you a better idea how it all works. So again, always when you start to make your stairs, think about the level you're starting on, and then check the top level in properties, and then have a look at the riser count and your riser height and your tread depth. Make sure you confirm all those settings, and then as you click to draw, have a look at the number of risers created. So if we need 24 in this case, I'll create 12. You can see there in the grey that comes up. And then if I go and start at a new point, you can see already the landing comes up automatically, connecting those two flights. And we can have it at an angle, that's fine. So if you look at this outside the building, then you can see it a bit more clearly. I might just go and put the risers back on those ones. So I want to show you how to take the risers off in a minute. But for now, you can see they're filled in, and this is how you probably have the stairs initially. Yeah, that's what I'm going to do next. So I'll do a curved stair. So, okay, so going back to the stair tool again, and again, changing the top level to the one I want, level 1. So again, remember I said this centre end spiral is generally the best one. The 4-step spiral is good for a regular spiral stair, but that's going to be very difficult in this building. So we'll leave that one and go to centre end spiral. So the thing that's different with this is that you need to give a centre point. So the first thing is the centre point when I click. Then you come out to give the radius. Right, so you can see once you come out, we can see the path of the stair. But again, it's just like the other stair. We can only have 18 risers before we need a landing. And because we need a landing, and I know we do, then it doesn't have to be at 18 where you have the landing, it could be at 12. So you can always check that. But I'll make it 18 this time, just something different. So there we are, so 18. And then you'll see it'll tell me I need another 6. So how do I start my next flight? Just the same as this one. So I need to get the centre point first. So here we've got a marker to show the centre point, and it's really important if you want to follow on from the previous one that you use the same centre point. And that's why they give you the marker. So we've got that centre point that we can use again. And then you can see if I bring it out and it's perfectly in line with the previous flight, the landing is going to follow the same curve. And that's where people often get into trouble when they're doing these curved stairs. If the landing doesn't follow that curve, you'll get a straight one, which doesn't connect very well. So just make sure, if you want it to follow on, that you get the curve from the previous flight. And now I can come around and add in those final steps. So again, finishing it. And I think the secret with stairs is not to try and do everything at once. So if you just use the stair tool with the right settings for your levels, that will give you the correct riser heights. And you can always make a new stair after that that has all the different flights and the path that you want for your final one. But at least making a stair with the right risers will give you a good idea how much room the stair needs to take up and other things you've got to think about. And then if you also want to model in around your stairs, you can do that. So I'm going to show you how to make some custom joinery units and things that can go in with these different stairs, maybe an internal access stair. And again, just having that stair model, we've done a lot of platform seating and things where you've got seating combined with stairs in the past. And again, just by making a stair to give you the riser heights, will then give you the basis for a lot of that modelling that you can do after. So I might just go to an upper level floor plan that you might be using for one of your units. And I've taken all the unit out of here, so there's nothing there, but I can at least do a stair. So you might have an external access stair over here, so I'll just go and make a new stair. And I'll start with the basic assembled stair, that 190 max riser, 250mm going, which you'll have. And check my levels, so from level 1 to level 2. And it tells us we need 22 risers. So again, we're going to need a landing. That's okay, so I'll just go from here, and you can see it's on the wrong side, so I'll change my location line to run left. And I'll do, I won't do it even, in fact I'll do 18. Yeah, because I want to get the headroom. And then I'll do another 6 over here. Okay, so I've got a stair running along my wall. So I'll finish that stair and I'll show you how you can do a few things with the properties. Okay, so I've got a section there that's looking the wrong way. So I'm going to flip it so it's looking towards my stair. Open that up and I can see the stairs. So do you all know what a cantilevered stair is? Yeah? Doesn't have, pretty much, yeah, it doesn't have the stringers. That's right. So yeah, that's all a cantilevered stair is. So it's supported from the wall, and they've got all sorts of framing that will go into the wall. Well, these days they just bolt in, and they've got these U-shaped brackets, essentially, that the stair then gets mounted on. And they're steel, so they're strong, and they can cantilever out from the wall. You need a bit of depth in your wall though. And there's some really good examples all around town, you'll see of those. So, to do that, it's really simple in Revit. Simply select your stair, go to Edit Type. Now you should duplicate, so you can keep the old stair type. Hit Duplicate, and I'll call it Cantilevered Stair. Oops. Okay, so I've got a new name. Hasn't changed yet though, so I'm going to go back to Edit Type, and then you've got the stringers. So in this case, I'm just going to set them all to none, or both of them. So I've just got the right support And the left support, set to none. Click OK, sorry. Yeah, you can manually delete them, but that's not doing it with the type, so then when you do your next stair, you'll have to delete them again. But now that I've done this, I can just make a new stair and it'll come up without any of these things. So that is a cantilevered stair, and I'll just show you in 3D. An easy way to get a 3D view of the stair is to click on this selection box button, and that'll give me a 3D view that goes just around the stair, which is a nice thing. And so I'm just going to bring out the section box a bit so that it's showing me a bit more. Okay, so I've taken the stringers away, and maybe I better just quickly put in a wall on that side so that you can see. Oh, sorry, the wall is there. I've just hidden it, so I'll just unhide that wall. Yeah. Okay, so you can see the stair there right up against the wall. So what else would you normally be missing if it's a cantilevered stair? Yeah, oh, the balustrade, yeah, so that's right. The railing on the left doesn't need to be there. Or the balustrade, yeah. Okay, so that's fine. But then what else would you take away? The risers, that's right. So if you're not sure, this part's your tread, and then the vertical part's the riser. So if you select the stair, again, go to Edit Type. What you have to do is change the run type. Oh, you could, yeah, you could keep it if you want to, yeah. And that's fine. If you're going to do the sort of modelling you're thinking about, that would be a good idea, yeah. So here, if we go to run type, notice it's a type. So you need to duplicate it as well. Okay, and I'm going to call this 50mm tread open riser. Oops, caps lock. Yeah. Okay, so then I'm just going to turn that riser setting off. And we've got your typical cantilevered stair. Real easy. Yeah, it is. That's the, almost standard thing. Oh, there is a way of doing something similar with the spiral. You know, the DNA stair? Yeah. So have a look at just Google DNA stair. Well, I'll do it for you. So that's... yeah. You can, yes, that's right. So you can have a straight column. These are these bending ones, but you can do a straight one as well.
I mean, the straight column, when you put it in the middle, so that's still attached to the stair, so when you pick up a line,
that's right.
you still have that link.
Yeah, you can do a straight one, absolutely. And then the other option is to have a middle stringer. So you can do a middle stringer as well. So, yeah, just in properties again. So if you go to here, and again, edit type, you'll see that's... yeah, that's my... oh, yeah, sorry, it's got to be here, middle support, sorry. Oh, yeah, you can do a middle stringer, no problem. So, no, it doesn't have to be against the wall. No, it can be anywhere. So, yeah, but it works well. It can look really good with the spiral stair. But again, if it's up against the wall, it can always be cantilevered like that. So then, once you've done the stair, that's when you can work out your opening into the floor above. So associated with the stair tool is often the shaft tool. So on the architecture tab as well, you've got shaft. And often you can just start with a rectangle that you draw over, or any shape that you draw over the stair that you've made. And that will just cut out that whole area. Well, I'm just drawing it over the stair at the moment. Yeah. Oh, I'll show you. So I'll finish this one. And then, no, it's fine, it's good. Okay, so here you can see in properties it's starting on level 1 but it's got that offset at minus 150. So I don't want it to start there, and I'll show you why. So in 3D you can see it's actually cutting the floor underneath as well because it's got that minus 150. And I don't want that. I'm just going to drag that arrow up higher, and you'll see that makes it higher than level 1. So it's not going to cut that floor. But it's cutting the one above, and I might stretch that down so that it only goes a little bit above that floor. So that gives us a void that is going to go through to our next floor, which is kind of good, but it's bigger than it needs to be. And you're probably pushed for space in this design, so you want to get it to be the minimum size possible, probably. So then, if you have a look in your section, you can start to work that out. Oh, well, you can't. It needs to go up here because you've got to have it at that height for the next floor. Yeah, so it does need to go all the way along the stair. You can change it so it doesn't go the full length, but you'd want it to go to the full end of the stair, otherwise you're not going to have the right balustrade height. So that shaft can be adjusted. If I select it, you can see we can go to Edit Sketch to change it, but where do we need to bring it back to? So what's the minimum height above a stair? Okay, you're close. All right, so what's the minimum height of a ceiling generally?
That would be an uninhabitable space. Standard thing, so it's 2100.
Yeah, you'd think so. So that is right. 2100 is normally the minimum. Yeah, 24 for living spaces, 2400. But for non-habitable spaces, bathrooms and kitchens, you can go down to 2100. But they've got an extra provision for stairs. You can actually go to 2 metres. Yeah, you can. I've been in court cases where we've done this, and it's a good thing. Because often where you've got little beams and things that come in over your stair, they do need to go fairly low. So, yeah, so you can go to 2 metres, definitely. So, that's just for stairs, only stairs let you go to 2 metres. So, how do we work that out now?
So you'd have to count on the ceiling.
Yeah, exactly. So how do we know where the ceiling is? There isn't a ceiling yet. I'm going to show you that next. So I'm going to draw a reference plane to mark where the ceiling would be. And then we'd say the minimum distance between your floor and the bottom of your ceiling. If you really push it, this is probably pushing it a bit too much, but we'll say you can go to 250 because I know you pushed for space. Yeah, you can do it. If you line your joists, you can go down to that. So that would mean floor joists. You could have 200mm floor joists with 20mm of flooring above. That's the absolute minimum. That's pushing it to the limit. Yeah, that's if you get down to 200 joists, which you can easily. So you could potentially do that, but it is pushing it. Yeah, that's it. So I've even done less than that. In some warehouse things that I've done, we got the floor joists down to 150, and then lined the top and the bottom, and but getting the wiring in and everything was a nightmare. But it worked, and they sold for over $1 million each of those actually. So you can do it, and so 250 should be fine, even though it's still pushing it a bit. So that's where the ceiling would be. So now I'm going to put in another reference plane that's 2 metres below that one. Right, so that reference plane tells us which step. So this step here, you might think it's okay, but it's not, because 2 metres is the minimum. So I know it's only a little bit over, but it's over. So that can't be it. It's what, 5mm over, but that's still too much. So if we measure from that step, you'll see it's 1995 again. So 1994. So again, that step isn't going to give you headroom, but the next step will. Right, so from there it's 2181, and that's absolutely fine. So then how do we know where that step is when we go to look in the plan? We can count them, of course, and try to remember, but that's the hard way. again, draw a reference plane. So if I draw a reference plane from the edge of this step, let's take it straight up and extend it down. Now I know when I go back to the plan, right, back to my level 1 floor plan, I can see the reference plane. So then I know if I go and edit that shaft, which will come up here, edit shaft, and or edit sketch, and then I can stretch that boundary onto my reference plane, check it all in 3D, and think of ourselves how we'd be walking up this stair, and you know almost by eye, you can see there'd be enough room from the step there up to the floor above to get you 2 metres. And this is where Revit's great, because in the old days when people were designing either by hand or even in AutoCAD, doing lots of separate drawings, you'd get away with murder, and people wouldn't realise that you'd left. I've seen almost complete buildings where they've left 1,500 between the floor and the stairs, and the poor builders would have to sort it out on site. So Revit's great, forcing you to do it in 3D and think about these things. And yeah, so we'll go on to balustrades later. Balustrades are a bit more involved, but for now, just make sure you realise that that awful vertical paling balustrade can easily be changed to one of the better options, like the 900mm pipe, which at least gives you horizontal balusters. Do you know what the limitation with those is? Yeah, that's right, exactly. When it's over 4 metres, I think it's 4.5 metres above the level below, you can't have these horizontal ones anymore, because again, kids are mostly, not just kids, but mostly, they can climb up them and... Yeah. Yeah. Yeah, okay, so yeah, so the minimum height, yeah, so the question is, what's the minimum height that you need before you have to have a balustrade? It's 1 metre. So once the floor level or the change in level is more than 1 metre, then you've got to have a balustrade. And that's why you'll see a lot of stairs, they'll stop the balustrade a few steps before the end, because then the end of it is less than 1 metre above the floor, and so you can have that open, and that's kind of a nice thing. But the problem with that now is that you've got to have a handrail on one side of your stair all the way along, and that's a requirement now. They might not be too picky with your designs for this project. You might be able to get away with more of a conceptual stair and not show the handrail with all the detail that you should have. But in real life, it's a huge thing now, not just having the handrail alongside your stair, but you've also got to have a projection for public stairs, not for private, but public stairs. It's got to project out at the end. You'll see it now in a lot of buildings where they stick it out for, I think it's 300mm or so straight, horizontally, at the end of the stair. They've got that extra bit that sticks out, which you'll see everywhere, which is, it was meant to be originally an accessibility thing, but now most people are getting used to it, and a lot of older people I know think it should be something that they go back and put onto all stairs, because it's a lot easier for them to, and you know, old people like me, to walk up and down these things. So it's becoming, yeah, almost a standard even for some private stairs. And you can put that in Revit as well. But again, we'll go further with railings later, as long as you can get the basic stair shapes you need. So the final thing I'll just show you, so you've got an idea what you can do with stairs before we look at a little bit of modelling, and then we'll get on to lighting after. Make sure you realise with the stair tool, that run tool is just the automated stairs. You can also draw your own sketch, and you can do any stair shape you like. It's a bit more involved, but you can. So when you go to create sketch, this is actually the old way, the way the stair tool used to be a couple of releases ago. This is how it was always done. So you've got boundaries. So the boundaries are the sides where the stringers would go. So I'm just going to do a length. So that's a green line. And I want this to be a slightly interesting stair, so I'm going to do the other one at an angle. Yeah, I know. There are some basic rules, but even then, yeah, it can be a bit hit and miss. But yeah, the basic principle is you've got the boundaries either side. They're the green lines, but they shouldn't touch. So they never meet. The two sides always have to be separate. And then I'm going to go to draw an arc. That's fine. You can do any shape you like for the boundaries. And then I'll do another straight line for the last bit of it. So then, this is where you'll see, I keep talking about AutoCAD because you'll find AutoCAD has tools that allow you to measure and draw 2D shapes like this a bit more easily. And you'll see the next part. When I go to do the risers, so here this is the boundary again, the green lines, then you generally do the risers, which are the black lines. And they're your steps. So in Revit, we can offset, with our riser depth, so say 250 if we want the minimum, or let's not do the minimum. The minimum's boring and not the best, so I'll go to 300. And that's probably better. Now, one nice thing with the stairs in Revit is that you don't have to trim your lines if the black lines are crossing the green ones, or if they're too short, that's fine. It'll live with that. Normally, it won't do this for other things. It'll make you join them. But with stairs, at least, you don't have to, which is kind of nice. So, how many is that? I haven't even counted, but it will count them for me. It says it somewhere, usually. Where is it? I'm blind. Oh, you've counted them, have you? Oh, yeah, okay, so you're probably sure you're right. Okay, so I'll say yes, so 12, that sounds right, and then I'll come to here for my landing. And then, now, what I was saying is that if you wanted to say do an angle now, that becomes quite a difficult thing to set out, those measurements. And there are tools and options for doing this in Revit, but it's very difficult. In AutoCAD, there are pretty simple options like the divide tool and the measure tool, which are perfect for setting out these measurements that you need to go around curves and things like that. So when I need to do more complicated layouts for my stairs in Revit, I'll go back to AutoCAD, especially if it's following an ellipse or something like that. Draw them in AutoCAD, import that sketch into Revit and just trace over it, and it works perfectly. Again, there are options in Revit for doing that, but I wouldn't even attempt to use those, even though I know how to do them, because it's a lot of work. So I'll just finish off putting in some extra risers, just so you can get an idea of all the options you've got for making a custom stair shape. So if I finish this now, now it'll tell me it's invalid. So because I've forgotten, this is normal. Because with the old stair tool, all you had to make was the green lines and the black lines, the boundaries and the risers. But with the new one, they've added this stair path, which is a good thing, because you then determine where the path is. It used to be automatic, and it's good that you can make it. So stair path, it's just center line. So you just draw a line through the middle, usually just through the midpoint, from the first step to the last step in each flight. You can draw curves, which is the nice new thing. And back to a straight one. There we are. So that's where my arrow is going to go as well. And that's actually a nice thing that they've added. So now when I finish it, this will work. Invalid sketch. What's going on? Can't create run by this sketch. What's going on? Yeah. No, this is normal. Yep, but don't panic. It's fine. It'll work. It'll work. This isn't a very complicated sketch. Now, the reason it's probably got some issues is because here. So the basic principle... Oh, no, that's fine. You can cross... Oh, yeah, you're right. Yeah, that's it. So, that's the main issue. You're right. Yeah, that's right. So that's it. The boundaries of the boundaries, the green lines, they should connect to the stringers. I'm sorry, to the risers, the black lines, and that, like Saul was saying, that's the most important one. But here as well, you can see that riser isn't quite on the end of this green line. So I'm just going to drag that to snap to that endpoint. And I'll just fix this blue line up as well, so they're all touching at where the riser meets them. And again, this is okay. I'm deliberately leaving that so you can see when I finish it. Bingo. So 19, right? So we know that's not enough. Remember, we need 22. So that's okay. I can select it, edit sketch, and then keep adding in more lines for my risers. Yeah. Yeah, yeah. Yes, of course. No, they've got a thing built in. So it's only America that does the up-down thing. The rest of the world, pretty much, is all up. So when you see an arrow, it's up. So you don't even need to label it. But I'll show you how to do that in Revit. They've got a thing for that because they make it for the rest of the world as well as America. Yeah. Yeah, yeah. No, I'll show you how to do it. Yeah, it's all in there. So, okay, so this is, so that was 19 to there. So 20, 21, 22. And then I've got to extend my boundary. And I don't want to just stretch this one, so I'm going to draw a new curve, maybe to bring it around and make it a bit nicer. Get a bit of a curve there. And then this other boundary can go up along that wall. Sorry, but with a straight one. And then I'll trim these things together. And that should work, except again I've forgotten the stair path like I always do, and so I'll just draw that in now. And again, maybe with a curve. Yep, that should be good. Okay, so again, finish, and it's all working. So you can usually make any sketch you want work. And so in 3D, I won't see it right away because of my section box. So instead of making a new section box, I'm simply going to adjust the one that I've already got so we can see the new stair. Okay, so there we are, and you can see it wouldn't really work very well with the stringer there. But remember, we've got the stair type that I made for the cantilevered stair that I can simply choose now because I've set that as a type. And I cut the hole in the floor afterwards. And get rid of some of these balustrades, maybe turn the other one to a slightly nicer one. And there we are. So, so Grace was one of the people who wanted to look at doing the modelling. I'll give her a minute, but are there any other main issues that you've had with stairs that were causing problems, or?
You're going to show changing the balustrade another time.
Yeah, we'll do more. Yeah, balustrade's fairly involved, but in fact, what I will show you, since we've got a bit of time, is the libraries. I don't want to go too far with this because it won't mean a lot until we spend a bit more time with families, but it's always good to get you started on it. So you all know, I'm sure, that if you go to tools like door, window or component and then load family, that takes you to the library. But have any of you tried loading in railings? So if you have tried, you'll find you can't. So I can load in a baluster, all the parts or a post, right? They can be loaded separately, but you can't load in a whole railing this way because they're a different kind of family. So all I want to get you started with is loading these other sorts of families. And one of the tricks is to open the file. And I know it's not obvious at first, but you've got to force yourself to not choose any of these options on the sub-menu. Just click where it says open. The reason you do that is so that it opens all of the supported files, not just one kind. Then you go to the metric library folder and then sample files, and you'll see there's a railing file there. Again, metric library, sample files. There are other places, but this has it. So, again, railings, and we've got all these basic pre-made railing types. So a lot of people, even people I've seen who've used Revit for a couple of years, think there's no railings library. But of course there is, you can see it right there. So I'm going to select one of these railings. Maybe we'll try the glass ones. The glass ones are a bit problematic because they've got panels that are a fixed size and they don't always line up with your stairs. But I'll try one. So I'll select this commercial glass with fixings, and it's important you look at the naming properties. And the trick to getting it from this file into the other file is to use copy to clipboard. If you're not sure why you should be using copy, this one here, as opposed to copy to clipboard, basically use this one when you want to go from one view or one file to another. So this other copy is actually great, you use that all the time, but only within a view. So this one, copy to clipboard, and then I'll go back to my file just using the tabs there, and then under modify, paste. And I'm just going to click anywhere, doesn't matter. Now it's telling me you can't see it in this view, not a problem. I'll go to a different view, and well, it's got section boxes, so we'll just turn the section box off, and there's my railing that I've just brought in. I don't care about that, I'm going to delete it. But I can go to any other railing now, and in properties, choose the one that I've pasted in. So by pasting it into this file, we've brought the type across. Sorry? Yeah, it's all recorded. Yeah. Okay, so there we are. So I've got that glass railing. Again, you can see sometimes you'll have issues with the panels not lining up with the shape of the stairs you've done. Okay, so I'll go back. And this is the nice thing about the tabs in the new version of Revit. You can switch back between files pretty easily and just try a different one. So let's try this one. Yep, copy to Clipboard, back to my other file, and I'll go to the view that shows everything and then paste. They are pretty bad. I mean, it's for commercial, but you can customise them, and I think one of the best things you can try is to make much simpler railings, just plain glass and things like that. And I've got videos on all that. It's a little bit involved, but you can do it. So now, again, I can choose my railing and choose the new name, Safety Guardrail, which has even more trouble on this one, unfortunately, because it's a bit of a funny stair. Let's try... here we go. There's a plain glass one, which kind of works. That's one I made earlier. Even plain glass can have its problems, again, when you've got that transition from a stair to a landing. But this is just an issue with stair design generally. You've got that issue with the transitions generally. And there are tricks. So instead of... Yeah, that's one option, but then modelling along that shape would be fairly tricky. So you can do that, but then another option is to try and use the stringer. So if I set the left stringer here, the left support, to closed, and then I'm going to go to that left support type and duplicate it, and I'll call it glass. And I'm going to set the depth to 20, and then the total depth to 1200. And, oh yeah, and then the width to 20 as well. And, now that's doing the wrong thing on the, what did I do wrong? Sorry, that's just me being stupid. Oh yeah, so depth on landing, so that should be, I should have left that one. That's got to be set down, so 150 or so, and then the depth here, 1200. Whoops. Is that right? No, that's the wrong thing. Sorry. I normally use a profile for this, but you can do it with the settings. I've done it before. So let's just try and play with that. So that's right. Yeah, that's fine. Yeah, I'll show you what the other option is. If you just get a family that I've made on the P drive, so on the Insert tab, I'll just go Load Family, Revit Library, and Profiles. And then there's a family there called Rectangle 20 by 1210, which I've made for this situation. And then you can set that, instead of putting in the sizes here, you can choose that profile. And then this can be 0 again. Is that right? I'll keep going down. Something going wrong there with that that panel. You can manually adjust it. Don't want to go too far with this, but you can do that. Why is it misbehaving? Normally this one isn't that difficult. Something funny going on there. I don't want to go too far with railings because they get pretty involved. So we'll try bring all that back to 0. yeah, it's got some issues there. It's always when you've got the transitions, but you can make it work, and I'll show you on the other stair, because that one's a bit more complicated, but here, there we go, you can see that's working how it should. And so there, it's just on the wrong side, so I can always flip that now. And this shows you why making types is important. You can see then it's just going to flip to the other side. Alright, so that's an easy way of doing a plain glass balustrade, but again, if you're doing unusual shapes, sometimes the connections you've got to play with, and I can go through that with you individually. You can adjust individual heights, but otherwise does the job. So then the final thing, I'll just come back to that stair, and so I'm going to set this one to have no railing, no support on either side, so it's just a cantilevered stair again. And then maybe because I know the ones of you who are doing building underneath probably want to have the riser, so I'll put the riser back to the previous setting, so it's got the risers again. So then, to model in cabinetry under the stairs, you can use model in place, and either use generic models or casework. So you'll see later when you go further into it that you can make a plane alongside your stair and then start to pick these treads and risers to make your cabinets. But the simpler option at first is going to be just to go to your plan and then make extrusions over the stairs. So you know your standard board thicknesses? Yeah. So if you're making a cabinet, it's generally made out of standard board sizes, which start at about 16mm and go up to about 35 or even thicker, but it's about that range. So you can even round it off and say 20mm for your boards and just make them all that thickness. So I'm going to draw a rectangle maybe over one of these risers and just bring it out from there. And then I can come back and select one of the sides and change that to 20. So that's going to give me my vertical pieces. And then I'm going to just put in a height, just guessing, might say that's about 1 metre, 1,000. Finish it, and then in the 3D view, just this one. Oops. Okay, so I've got a vertical board. Then I can stretch it there and it will snap to the steps. So it's going to line up perfectly. And then you've got the option of just making more rectangles the same way, or alternatively you can copy that. And again, it's just like the way you would build this. The cabinet makers or the joiners or the carpenters would do exactly this. They'd get flat pieces of timber and cut them to shape and position them, and that's what you're doing. So back into plan, and always check that that lines up with a step, and if it doesn't, I can use move. But notice it's hard to look at this now because the line weight is covering up a lot of the detail. So do you remember what to do to hide or to turn off the line weights? Oh, you can use, yeah, there are different display options, but there's a really good one at the top, thin lines. Scale will work as well, but thin lines is good, and that just turns all the line weights off. So now I can select that box, click move, and snap it from the back onto my riser. And then checking in 3D, so you can probably tell already, the key with a program like Revit, unlike SketchUp, is that you have multiple views. You can always check things in one view and then go to another, and the views are already set up for you. They're all stored in your project. You don't have to keep changing your views. And it's important that you do look at different views because the plan view is only going to tell you certain things, and the heights and the way things line up is only going to come from 3D. So you can see these things look like they're lining up in plan, but in 3D we can see they don't actually line up perfectly. Right, so we can use options to move those in 3D. And that works. There are better ways, but this will do the job for now. If it's by eye, that's fine. So they're the vertical pieces, and then to make the horizontal pieces, again, basically the same way. In plan, you can make more extrusions. So you might start out with just one big shelf type piece. And then again, back into the 3D view, or use the tabs like I should be to switch. So I've got this huge box, but I can then adjust the start point. So do you know what the standard height for a kickboard is? 150 is not bad. For a more design approach, 150 is good. The standard height's actually 100. But 150 is nice. It's a bit more designer, and it's going to probably line up with my treads pretty well as well. So maybe I'll start with 150. Now here, if you wanted to line up with your steps, you might think about your riser height and use that for your shelf height. So it lines up exactly with your steps. But sticking with 150, if we want a 20mm thick board, what's the top going to be? Yeah, you'd think it'd measure from the last one, but it's always measuring from the bottom. So it's always measuring from the same place. So it's 150 plus the 20. Yeah. So 20 plus 150 equals 170. And then I'll stretch this across, and you can see it's not far off my riser height, but we can tweak that a bit further to get it to line up exactly. So how do you check that? Go and have a look at your stairs. And we can see it's 187. So remember, when you're working with things that you've modelled, you need to go to Edit in Place to change them. Don't go back to Model in Place. Okay, so here I could start, also I'll end at 187, and then I'll come down 20mm from there. So this will be 167. And that's going to line up exactly. Or I could try and even make the thickness of the shelves the same as my treads. Got all those different options. And so this is simply working with extrusions. We'll look at all the other modelling tools like Blend and Revolve and Sweep later on. So then you can just keep building from there. So if I've got vertical pieces, I can keep copying those to make whatever pattern you want. And you can do beautiful Mondrian type designs simply with a pattern of shelves and some colours. And this is really common under stairs. It's done all the time. And like I said, I've done an apartment that was pretty much all units like this that made up the stairs and all of the different cabinetry around the bedroom and the living room and everything. So I'll just show you one last trick. To get this piece copied, the copy tool isn't really going to help us much, because I want to copy it up. I don't want to copy it left or right. So here, I'm going to use Copy to Clipboard instead. And then click on the down arrow under Paste and choose Align to Same Place. So there's a copy in the same spot as the original. And now I can go and type in a different height. Okay, so to go to the next step, so what's 187 times 2? It's 374. I think it's 374, isn't it? Yeah. Okay, so that lines up exactly with the next step. Or we can have another 187. I don't know how to do the maths. Let's use a calculator. Okay, so 374 plus 187, so 561. And then 20mm below that, of course, so 541. And then you can use the arrows to stretch it to line up with the back of your step or whatever. So I can't help it, I want to show you one last thing because it looks pretty awful with the steps being a different thickness to the shelving. Now I'll show you two things, sorry, because I've done 20mm board for the vertical, but what thickness should a shelf be? You might not know if you don't need board thicknesses. It's not 20 or even 18. You make it the next one up. Normally, shelves, 25 is the basic rule of thumb. So yeah, 33 or so for bench tops, or 35 or 30, but yeah, 25 for shelves is good. So here it would be, if it's 561, another 5mm down from 541, so 536. And this one is, again, another 5mm down, so 162. So I'll finish that. We'll join it all later, but I don't even mind having the joins. All right, so now I want to make my steps the same thickness, the treads. No worries. Edit type, go to the run type, browse, and there's the tread thickness on 50. We can go down to 25, that should be okay. Especially if you've got the cabinet to support it. And there we are, how much better does that look? Just going to bring these bits up. And again, edit in place makes that easier. Okay, so like doors and things. Yeah, no problem. So same basic principle. Doors are flat. So you can make them all with extrusions. You can make them in elevation so that they have, if you need the notches, you would need to do that. So I'll show you that. So there's just one extra step, which I wanted to show you next week, but since you asked, I'll do it now. On the Create tab, I'm going to make a reference plane. So I'm just going to draw along the side of the stairs, because that's the line where we want the doors to be. And the key to this is giving the reference plane a name. And most of those solid modelling tools you'll see, they rely on the plane that you're modelling in to create the profile. So I'm going to call this side of stair. Oops. Caps go away. There we are. Okay, so now if I go back to that 3D view that I had, this one, I'm still in the family, remember, I haven't finished the model. So back to create, I'm going to go to extrusion, but before I draw anything, I'm going to click set. Now sometimes it'll come up with this dialog box without you having to click set. But either way, if it comes up automatically or you've got to click set, you still do the same thing, you choose the plane that you've named. So that's the key to it. You've got to give the plane a name so that you can select it here in that list. So now if I click OK, from this point it's fairly easy. I can make, again, also I'm already making an extrusion, so I don't need to click on that. Just with the pick lines tool, I can actually pick things in 3D. And this is one of the best things about Revit. This is why I like it still a bit more than ArchiCAD. ArchiCAD's got some great stuff, but this is not as good in ArchiCAD. So I can pick all these things in 3D and it projects them onto the plane that I'm working on. And I'll turn thin lines off now so you can see it a bit more clearly. And that's why it's good to flick thin lines on and off. You don't always want to leave it on. It's sometimes better if it's off so you can see the lines that you're making stand out a bit more. So now I'm using trim to corner just to join all of these lines so that they touch. Because it has to be a closed shape, of course. And then before I finish it, I'm just going to think about the settings over here. So it's on 0 for the start, but the end, I'm going to make 20. So it should come out 20mm from that reference plane. And there we are. So, yeah, that could be really good in the end. And yeah, you can do beautiful things just with extrusions because nearly every joinery piece in the world is made from flat board. Even the curved stuff. I know I used to make this for a living. They get flat pieces of board and they cut notches in the back and they bend it around the frame that's made of flat bits. So it's all flat, which means the extrusion tool will let you make nearly everything in joinery and cabinet pieces. So that's all there is to it. And yeah, so we'll go through definitely the other modelling tools that you can use with Model in Place. Again, just to remind you, extrusion, we'll keep going with that, but then blend, revolve, sweep and swept blend are the other main tools. We'll go through that next week. And don't think that's all you can do with Revit. Remember, that's just the beginning of modelling. If you really want to push it, you've got massing, and then you've got all the options for importing geometry from the really advanced modelling programs like 3ds Max, which we'll go into later as well. But that's just to get you started, but again, it's all based around the construction process. That solid modelling approach is very close to the way people build things in real life. And that's why it's set up the way it is. Yeah. Yeah, of course, yeah. So that's all I want to do with stairs, probably more than I wanted to, but it's good to think about all those things. And so I want to try and go through lights at some point today, because that's what I really wanted to look at, to finish off rendering. And yeah, I do want to look at solid modelling a bit more, but we've probably done enough for today.